Sorry, we recorded a little late here, but this is an isosceles triangle, and we want to make this is number, what is it, 7? So it's number 7 on page 304. Okay, so this is an isosceles triangle with a base of a units long, correct? So that means the length of this right here is a units long. But that's not how we're going to label it. How do we label it? We label the what? The points, right? The vertices, okay? Label the vertices of the triangle. All right, I heard it. What is this point right here? Yeah, that's the obvious one. It's 0, 0. Now, if the base is a units long, if from here to here is a, then what is this actual point right here? It's a0. Good. Because if it was 5 units long, it would be 5, 0, wouldn't it? Make sense? But it's a units, it's a0. Or I could have labeled it something else, because you got to label this one as well, don't you? Remember what we said yesterday? Yeah, and you could have said A0 and that would be fine. All right, that wouldn't be wrong. But since we're trying to label this point as well, it might be a little easier for us if we call this 2A. Now, actually, we can't do that, can we? I'm sorry, because I'm getting somewhere else. I'm thinking somewhere else. But we have to call it A0 because it says the length of the base is A, correct? So we can't call it 2A. All right. But what would I call this point right here? That's right. So it's 1/2, right, A. So like right under here, that point right there would be half A, wouldn't it? Or A over 2. Might be easier to write it A over 2. So that would be A over 2 what? How far up? Yeah, this could go up all kinds of different distances, couldn't it? I mean, it didn't have to go exactly right here. It could have gone way up here, it could have gone down here, it could have gone anywhere in between, right? So I just have to pick a certain value for how high up it goes, and so I'll just say it's B. So it's, I don't know, I haven't looked in the back of the book.
They did it so that like your top point was on the y-axis, and you didn't have one of the points at the origin.
Oh, did they? All right, let me take a look at it. Okay, what they did, I tell you what, we'll stay on the same x and y axis, just do it in a different color, okay? So what they basically did was this. I kind of like it just staying in the first quadrant, to tell you the truth. But they did this. They went, I don't know, I won't go exactly over to that. Let's make that a little thicker. And then let's go over. Does that look about the same length? I'll tell you what, I'll just do this. I'll copy and paste it so it is exactly the same length. I know. Oops, come on, grab the thing. There it is. About right there? Okay. So that's our base. Now, they made it the same distance here as here. Why? So that 0 would be, 0, 0 would be what? The midpoint, exactly. That's why I made this length the same as this length over here. Does that make sense? All right, and then let's say we had a point. We'll just take it to B. Is that all right? Right there. And so you make your isosceles triangle to there, to there. I like my way better. Yeah, I agree. So now the base of this, now remember this and this are equal to each other, right? The base is A, isn't it? So that whole base right there is A. So what would this point be right there? Now if this is 0, if right there is 0, yeah, this would be not 1A. You guys said it already. Half of A, and this would be negative half A, or A over 2. Let's call it A over 2. It's a little easier, okay? So this right here would be positive A over 2, and this right here, since it's the same distance, right, the same length, it's just going in the opposite direction, this would be negative A over 2. But what's the ordered pair, though? That's what we want. We want an ordered pair. So this would be what? Negative A2, 0, and this would be positive A over 2, 0. See that? And then what's this point up here? It'd be what? 0b. It'd be 0b because it's on the y-axis. All right, so that would be 0b. Does that make sense? I definitely like my way better. I think it's a little less confusing. And that's what they told you. I mean, I'm surprised that they would write their answer like this. But it just shows you don't have to have the same exact triangle. Everybody's answer could be slightly different, okay? Both of those, the yellow one and the red one, are really the same. This is right here. It's page 304, number 7. So, so they could be slightly different, right? There may be 3 or 4 different ways to draw this, but that's one of them. I like my way a little bit better, staying in the first quadrant, but you can kind of see how this would work too, don't you? All right, we could have you know, one of the sides is the axis, and that middle part 0b, or we would have had to call this a over 2b, so that's a little bit more confusing than that. But this one right here is a lot easier than that, isn't it? And 0, 0 is a lot easier than that one right there. Okay, yeah, so I like my way better, but you kind of see what we're doing. Does that make sense on how we set these things up? That's what basically 7 through 18 is basically setting them up for your proof. We haven't even done a proof yet. I didn't even assign a proof, okay? If we have time, hopefully we'll be able to do one at the end here, an actual proof using this stuff. All they're trying to do is just getting you warmed up for this, all right? Now, I can't do every single one of these problems, but let's pick a good one. 11?
Yeah, because
all right.
the answer is like square root of 2 plus.
Yeah.
Okay, so it's kind of crazy. All right, let's take a look at it. Okay, an equilateral triangle with sides half a, or a over 2 units long. Equilateral triangle. Okay. Let's do this. Yes. Just not right now. I'm right in the middle of doing this. You have to do that after class. Let's go blue. And let's make this a little thicker. All right, so equilateral triangle, correct?
Yes.
Alrighty. All right, I think we can just stay in the first quadrant. You? So what am I going to do? I'm going to copy and I'm going to paste it, right? Now, it's an equilateral triangle, so you know how many degrees it's going to be, don't you? Now, I'm going to be a little bit, what would you call it? Let's rotate it. And let's rotate it what? 60 degrees, right? There it is. Look at that. Now, you can just draw it by hand, couldn't you? I'm being a little bit more particular. And then I could copy and paste this and then reflect it about the vertical, and that should be the same thing. Yep. Look at that. Perfect. Pretty, huh? All right. So, but you could have just drawn that yourself, right? So let's put some points in here. Let's make this a little brighter. I like the yellow. It shows up pretty good. So this point right here is 0, 0, right? Now, what does it say about the lengths of the sides?
That they're all 1.
It's 1/2, right? So all the lengths of the sides have to be 1/2. So what is the ordered pair for this? Right, it's 1/2 a, or a over 2. I like a over 2 a little bit better. 0. Agreed? But what would this point be right here? Okay, yeah, because this is halfway, isn't it? Right, because again, they're all of them are equal to each other. Would you agree? So this is going to be halfway between here. So what's half of a half? It's a fourth. So this would be a over 4. Yeah, and then how high up? Now that's the key. Now we don't want to just say b. This is where you get that square root stuff. Okay, this is where you have to think a little bit. This gets a little bit tricky. So it's not just b, because this is equilateral triangle. It's not just any old, because I couldn't take this point. Remember before I said that on the isosceles triangle, that top point could be way up here, it could be way down here, it could be anywhere in between. Remember that? But is that true about an equilateral triangle though? No, because if I took this point and I put it here, then it's not an equilateral triangle anymore, is it? If I took it, yeah, but I can't change the base. The base has to stay the same though, right? That's the key, because it's got to be equilateral. I can't take this point and put it way up here, because then it changes it. Now it's not an equilateral triangle anymore. Make sense? So it has to be here. So there has to be a specific place where that point is. So it's not just anywhere, because B would represent what? It's any point at all, right? So I can't just say B. I have to figure out what the length is from here to here. I didn't hit the middle exactly, did I? And let's make that purple. Okay? So that's what I'm trying to find right there. I'm trying to find that distance. If I find that distance, that's what this point's going to be right here. Does that make sense? And then I can put it into that ordered pair. So how in the world do I find that length right there? Well, what does it look like? Looks like a right triangle, doesn't it? And it bisects this as well, doesn't it? Okay, so what is the length of that right there? No, you're just saying things because that was the answer in the book, okay? Look, this right here, the whole thing is half of a, right? So this is half of half, so it's what? It's a over 4. So that length right there is a over 4, correct? Okay. Oh. Do you know enough stuff to be able to do this? You got to be.
Why is it half A?
Because it says the length of the side has to be half of A. That's what the problem says. Okay? All right. This is the only way that I know, and I'll ask Mrs. Bonsbach or something. She might be able to figure it out. But to find this length right here, I'm not sure why they put that at this point in your geometry career, because you haven't learned this. But eventually you will learn this, okay? If you look back and watch this video towards the end of the year, you'll look back and say, oh yeah, now I know how to find that. Let me just show you. Now look, I'm not going to expect you to be able to do this. Just sit and watch, so no complaining, please, okay? All right, don't hyperventilate here because you see something you haven't seen before. Oh, there it goes. Why did it hiccup? I don't know. All right, so that's 60 degrees. Now watch. If this is 90 and this is 60, that's 150. What's this little angle up here? That's got to be 30. And it also bisects that 60, okay? So I have a 30, 60, 90 triangle. We're going to learn something a little bit later about a 30, 60, 90. We're going to learn that the hypotenuse is equal to, now I got to remember this thing. It's the hypotenuse is it's 2. It's twice the short side. 2 times the short side. Okay, so what is the short side here? It's a over 4. No, they're not. Not on this right triangle, they're not. Okay, the short side is a over 4, isn't it? Okay, so this would be twice a over 4, which would be what? It'd be 1/2 a. Yes, it would. And it should be 1/2 a. Why? Oh, you know what? Now I see it. Oh, good. Thank you. Goodness. We don't have to do that. We'll save that for later. I don't want to blow your mind. I should have thought of that. I can't believe I didn't see this. Because it's an equilateral triangle, isn't it? It's an equilateral triangle. So if this length from here to here is a over 2, what is this length from here to here? It's a over 2. I can't believe I didn't see that. There's probably people watching this video thinking, you idiot, why didn't you see that? Now I do, okay? So now this is a over 2. So now how can I find this side right here? I can do what? I got a right triangle. I got 2 sides of a right triangle. Pythagorean Theorem, exactly right. I could do Pythagorean Theorem and I could solve for this side right here. You know Pythagorean Theorem. We've done that before, right? So let's do it. So we don't know this, do we? We'll call it x. Is that all right? So we don't know that, so it's going to be this. It's going to be x squared plus this thing right here. What's that length? A over 4 squared, right? Equals the hypotenuse squared. So that's a over 2 squared. So watch what happens. Now remember, we're going to have a as part of our answer, aren't we? Okay, so we're solving for x. Let's go through it. Then you can ask questions. So x squared plus, let's figure out what that is. What is that? A squared over what? 16, right? Equals, what's that? A squared over 4. Subtract a squared over 16, right? A squared over 16. Do you see that? And then x squared equals, let's figure out what this is. We've got to find a common denominator, which is 16. 4 times 4, and then 4a squared, correct? Minus what? A squared. See that? It's just adding common denominators is all it is. That shouldn't be confusing. All right, I see these looks on your faces like, what in the world am I doing? I just found a common denominator is all I did. Because it's 4 times 4 is 16, so 4 times a squared. It's just a common denominator. All right? Okay, so now let's do this. So x squared equals, here's some algebra, 4a squared minus a squared is 3a squared over what? 16. Now here's that crazy answer they give you. How do we get x by itself? Take the square root. So we take the square root of this. So look what we get. What's the square root of 3? We just write the square root of 3. What's the square root of a squared? It's just a. And what's the square root of 16? It's 4. That is the length right there. So the square root of 3, well, let's do this. So how high did we go? What is the length of that? What did I say? It's down here. It's square root of 3 over 4a, right? So it's the square root of 3 over 4, and we'll just put an a right there. Your answer key said the square root of 3 over 2, didn't it? Did it give the first one as a over 4?
Square root of 2 over 4.
For the first one?
No.
No, I'm saying for the first one. What did they give you for the first one? Oh, see, they did it a little different then. See, they must have, did they draw it with this I'm not sure. It should be this. What I did right there was correct, okay? If one of the sides is a over 2, then this point right here. Did they draw it all in the first quadrant on the answer key?
Yeah.
Did they? Yeah, I don't know why. They messed up somewhere. Because this whole length right here was a over 2, so this is a over 4. Okay, so that point's a over 4. We found out that distance, and it's the square root of 3 over 4a. That's it. So those are your 3 coordinates. Wasn't that fun? It was just Pythagorean Theorem. I mean, if you really think about it, look, go back and try this on your own. I know I went quickly. I did record it, right? So go through this. I know I went a little fast. Maybe I kind of lost you a little bit. But you do it. You actually write this stuff down and try every step. It'll make sense to you. It's really not that difficult. It looks a little crazy, but it's really not that tough. And I know you can do it if you just take your time with it. All right? All right, here we go. Here's what they give you. They give you they give you a triangle, right? They say that this side is equal to this side, and you just got to fill in the blanks, right? All right, well, let's take a look at this point right here. Look at this point right here. Let's do that in a different color. All right, see this point right here? They already told you the length, or they told you that the x-coordinate of this point. So that means from 0, 0 to here is 6a, isn't it? Well, how far up did we go? 0, so that was easy. Everybody should have been able to do that, right? Okay. What about this point right here? I'd say the vast majority of you should be able to get this. Because if you went over positive 6a, and this is an isosceles triangle, this has to be the midpoint, correct? So this goes, because the vertex is up here on the y-axis, so this is negative 6a what? 0. Easy. Okay. What about this point right here? This is the halfway point. The x-coordinate of this is the halfway point of this, isn't it? So what is it? Well, the x-coordinate. The x-coordinate. It's 0, right? It's 0, isn't it? Okay. Now, this is an isosceles. So this point really could be down here, could be up here, could be anywhere in between. Is there any way we can figure out exactly where that is? There's really not. So what do you want to call it? It's called B. Yeah. That's it.
That's it.
3. It does. I mean, it could be 3, but it doesn't have to be 3. It could be 2, could be 1, could be 5, could be 100. Now, listen. Think of going this way. Think of this way, okay? If you're at negative 6 here and you're at positive 6 here, 3 is not in between negative 6 and positive 6. 0 is between negative 6 and positive 6, okay? As far as going up and down, does that 6a have anything to do with going up and down? It's got nothing, because I could have taken this, right, scooched it down here, right, and made an isosceles triangle that looks like that, couldn't I? So that B could be anywhere up and down. Follow me? That's why it can just be B. It doesn't have to be a specific place. Got it? Okay. Now, man, we don't have time. I really wanted to do a proof on this. If we had like another 15 minutes or so. Let's do one of the other ones on here. That was what, 18? 16? All right, let's do 16. Let's do 16. What haven't we used that'll show up good? Let's do this light orange. What is that? What is that? Sunshine. I got sunshine on my shoulders. You don't even know that song, do you? 16. John Denver. You guys ever even heard of John Denver before? Who? Oh man, you guys are missing out. Is it?
Oh, never mind.
It's like
Right. Yeah. See, when you have it selected, it does. I'll just now.
now we can't.
It's an isosceles triangle, but it's an isosceles right triangle, isn't it?
Oh.
Okay. And then I'll do this. Rotate 90. There we go. I could have just drawn it, but then, see, I copied and pasted, so I know it's the exact same length. There we go. Alright. And then, there we go. Alright, we got it. There's a nice little triangle. And they say it's isosceles. So this side and this side are equal to each other. It's also a right triangle. They didn't even have to tell you it was a right triangle, because if this is along the y-axis and this is along the x-axis, it automatically has to be a right triangle. Would you agree?
Yes.
Okay, and let's put some points on here. So this is, we don't know, either one of those. They put 0 then question mark, like that's even. Oh my goodness, these are all easy. Watch. This is 4a 0, right? Let me just see something here. Where'd they put oh, there it is right there. Okay. So what's this point right here? 0, 0. How hard is that? Okay, what about this point up here? It's 0 something, isn't it?
Zero B. I like B. I like B.
That's right. It has to be 4a. It can't just be b because look, this length and this length are the same, aren't they? Okay, so if this went over 4a, this has to go up 4a, right? So this has to be 4a. It can't just put a b there. All right?
After we just write that down, that's all we
That's it. That's all they want you to do. Is just label the vertices. That's all they want you to do. See?
find it. I was like,
See? That's 4a and this is 4a. Agreed? That's all they wanted. So here's your answer. It's that, and that.
it was way easier.
I told you it was easy. Did I do 7? Yeah, I did.
That was the very first one.
It's on YouTube. You can check it. I don't know. 16. This was 16. All right. We got time. We can do another one. 8. Oops. Gotta recopy my X and Y axis here. Well, I copied that line to make it over here, so that's what. There we go. They should have a button where you can push where you can like copy like the previous thing, the one before that. Yeah. That's what we're doing. There's you can't really like read them off, I guess. That's what we're doing. So what do we say? 8. Wow, that's a long one, isn't it? All right, let's try to draw this thing. We'll go blue. Oops, sorry. There we go. It says we're going to draw a right triangle XYZ with a hypotenuse YZ. So let's draw a right triangle. I would keep this within the, but it also says something else too, doesn't it? I might not be perfect with the lengths on this. Let's see what it says. It says XY. Oh, okay. The length of XY is B units long, and the length of XZ is 3 times the length of XY. Why are we packing up? We shouldn't be packing up. It's not time to go. All right, that's kind of rude. So the lengths of XY, so it's XYZ, is B, and so one leg is B and the other is 3 times B, right? So we'll do it like this. All right, and let's make that thicker so I can see it. Make it 3 point instead of 2 point. All right, so here we go. We've got this, and we'll call it XYZ. XYZ. Let's make this smaller if I'm going to write with it. It says the hypotenuse is Y. Oops, I can't make it that because it says the hypotenuse is YZ, doesn't it? So if this is Y, that's got to be, that's Z, and this will be X. Let's see if that works. Length of XY is B. All right, so that's B. The length of XZ, good, is 3 times that. All right, so here we go. And we got to figure out what these points are, right? That's basically what we're trying to do here. Everybody watching? So X is an easy coordinate. It's 0, 0. It's a right triangle, isn't it? Now it says XY is B units long. Okay, so from here to here is B. So what's the ordered pair? 0B. So how easy is that? Then look, what's this ordered pair right here? It says that XZ is 3 times the length of XY. So the length is 3 what? 3B. So what's this ordered pair right here? It's just 3B 0. See? I told you this was easy. I wasn't lying. All right? And that's all they want you to do. That point, and that point. That's what they want for your answer. It's as simple as that. Does that make sense now? Good. All right. Why don't we just turn it in? You don't want to hang on to it during the break, do you? All right, so put your name on it. Put the section number. Okay, listen. Put the section number. Don't forget that, because what do I do if you don't put a section number on there? What do I do? Take a point off. Take -1 if you don't put that on there. So make sure you have that on there. Okay?